Hi everyone, today I'm going to introduce polynomial. A polynomial function is a function of the form as below. So where a0 to an are constant. And very important, an is not zero. So in this function, x is the variable and a0 is the constant term. An is the leading coefficient and it's non-zero. So ar is the coefficient of x to the power of r. N is the degree of the polynomial being the highest power, okay, I'm going to highlight it, highest power of the variable. This table summarizes polynomial functions. As you can see, the first one is degree 1 because the highest power in this polynomial function is x to the power of 1. And the second we are pretty familiar with is called a quadratic because the degree is 2. The highest power in this function is 2. And same way, the number 3 is cubic and number 4 is quartic. So let's have a look at all the other conditions. We've noticed that a cannot be 0. Why is that? Let's give the quartic as an example. If a equals 0, what will happen? It will become 0x to the power 4 plus bx to the power 3 plus the rest. So there won't be x to the power 4 because a is 0. So it's no longer a quartic anymore. So it is very important to pay attention that a is the leading coefficient and it's non-zero. Okay, let's have a look at this example question. I would highly encourage you to write it down in your workbook and then copy this as example. So there is a polynomial of g of x. State the degree of the polynomial, which is pretty easy. We can just focus on the highest power in this polynomial. In this case is 4. And the leading coefficient, again, is 3. Constant term, negative 10. Okay. Coefficient of x to the power of 3, we can see it is negative 2. And the coefficient of x to the power of 2. So you can see that is there a x to the power of 2? No. So can I say that x to the power of 2 can be written as 0 times x to the power of 2? Okay. So, and that becomes 0. So, and that is the reason why the coefficient of x to the power of 2 should be 0. Okay. Let's have a look at this example. Find the leading coefficient and constant term of px. So a way to do a question like this is by opening up the bracket. Okay, so I'll do that here. When I open the bracket, I just times 1 by 1. So you can actually draw this line to help you to know that you're not really missing a term. So 2x times x to the power of 2 is 2x to the power of 3. And then I'm timing this plus 10x to the power of 2. And then take 8x, which is that. And take 3x to the power of 2. Take 15x. And then plus 12. Okay? So, and then you can collect the like terms. Okay, so the question asks you to find the leading coefficient. Which after expanded is very obvious is 2. Okay, and the constant term will be positive 12. As you can see that you don't actually need to expand it. You can see the leading coefficient can only be achieved by times the 2x with x to the power of 2. Because 2x is the highest one in the first linear factor. And x to the power of 2 is the highest in the second part, which is the quadratic. So it can only be achieved by times 2x and x to the power 2. So you know the leading coefficient would have to be 2. And again, same way with the constant term, you know that it can only be achieved by times -3 and -4. In other words, the constant term in both factors. Let's have a look at this example. So I want to equate these two polynomials. Therefore, I want to find a, b, c from my equating of polynomial. Same way, you can do this by expand the right hand side and then equating the coefficient with the left hand side. Okay, I'm just opened up the bracket of right hand side, and then now I'm just gonna equating both sides. Okay, now I have my constant term immediately equal to 7. Therefore, my negative c is 7. C equals to -7. Okay, and my leading coefficient, which is 6, 2a equals to 6, a equals to 3. And my x to the power of 2 part equals to 7. Therefore, 7 equals to 2b, take a. 7 equals to 2b, take 3, b then equals to 5. Okay, so you can actually do this by equating both sides. There is another way of doing this. So this is method 1, which is by just expanding and equating. Okay, there is an easier way to do this, which is method 2. Okay, method 2. So you can see that the leading term can only be achieved. So this factor is a linear factor with a quadratic. So the leading term, leading coefficient can only be achieved by times the 2x with ax to the power 2. So you can actually by inspection, you know immediately 2x times ax to the power 2 equals to 6x to the power 3. You know 2a equals to 6, a equals to 3. So without even expanding it, you can actually see that a would be 3 to achieve 6x to the power 3. Okay, you also can notice that the constant term is positive 7. That can only be achieved by times -1 with c. So you know immediately that negative c equals to 7, c equals to -7. So without even expanding it, you can actually calculate a and c. So, and then you can choose which term you want to use. You can either use 7x to the power 2, or you can use -19x. So if I'm choosing to use 7x to the power 2, I have to find, after expansion, which terms times together will give me x to the power 2. Then I know that if I'm using 2x, then will have to be times 2bx. So one of the x to the power 2 term will be 2bx to the power 2. And then if I'm using the constant term to times it, when I do expansion, I know that it can only be achieved by -1 times a x to the power 2. So take away ax2. That will equating 7x to the power 2. Therefore, I know 2b take a is 7. My a is 3, so 2b a is 3, 2b is 3 plus 7, 10b equals to 5. So you don't really need to expand it to be able to get the result.